Today we're adding Lisp-style function calls to RLMeta so that we can write COI semantic actions more clearly. So what we want to achieve here is to be able to write first of all, just convert it to like Lisp style. So what that means is that the parentheses come first. So this in Lisp style, this would be written as like that instead, and msum would be written like that. Let's see if I can format this. Something like that. So that's just a syntactic change, which will make operators easier to read, because this could then be written like this is my idea, this with plus, and this with %. So we would have like a, let's see, like a special case where this can not only be a name but also an operator. And if we would write the operators just like this instead, I think it would look quite weird. Oops. So what would it be? Something like this. I mean, this reads really weird, I think, because I'm not aware of a language where you can, where the function call syntax is like this and it can also be operators. Perhaps there is, or perhaps it's just me being unused to this syntax. But I think this looks more familiar to me, and that's what I would like to go for. Before continuing, I would like to remind you to give this video a thumbs up if you found it entertaining or useful, and also don't forget to subscribe to this channel if you want to see more videos like this. Okay, back to coding. So my idea is that I want to replace the function call syntax in RLMeta. One way to achieve that is to add another case here and say if the space, then the parentheses, then the variable name or the function name here, that would also generate a call. If we just add that, RLMeta compile itself, so that works, but this case will never be used, right? Until we start using it. But we can now, for example, let's undo all this. So now we can, for example, instead of writing set parentheses running, we can do parentheses set running, and that should work now. Right. The problem with the two versions of function calls is that they interfere with each other. Take this grammar, for example. Here, the code should be interpreted as a function call to foo with 2 arguments, but instead it is interpreted as a function call with 1 argument, and that argument is a call to a function called bar. Let's see how we can solve that. What we need to do here temporarily is to introduce another syntax for Lisp function calls that doesn't interfere with regular function calls. And let's see if we can use just a different symbol. So I'm not sure in host expressions format. Perhaps we can use the angle brackets. No, not really, because Yeah, the angle brackets are taken as well. How about if we just do if we do double parentheses? I would always prefer that. So if we find a double parenthesis, we assume it's a Lisp-style expression, sure. And now this will not parse, so we need to do double, oops. And this closes that, closes that, closes that, closes, oh, let's see. Closes that, closes that. This is like double Lisp syntax or something. And we need double there as well. Or yeah, so now in this case, set will be a name, and then the host expression, it will parse. This is no longer, or maybe it is a function call. What is this? Is this parsed as a function call? No, I don't think it is. Because, okay, so let's assume we will end up here, so it will match the first name, var will match running, and then we will match the first parenthesis, and then this should match a host expression. So this part right here, it will not match anything, because it will not match this case because there's not two parentheses, and it will not match this case either because there's no variable before. So yeah, nice. Okay, I think I've done all replacements now. So at this point, we should be able to remove this one, because that one should never be used in RLMeta itself. It's used in Koi, but we should get here that RLMeta was able to compile itself. So let's see. No, where did it fail? Wrapper X. Okay, rule. Okay, so I forgot one place. An assembler rule wrapper. This one. Let's try to remove it again. And now we get the error in Koi instead, and that's totally fine. So what we can do now is we can add a case for just a single parenthesis. I think. Let's see if we can do that. Okay, so this is an error. Okay, let's see. Let's restart this one. So this is an error in Koi. So yeah, we're fine. Yes, and now we can remove this one. Yay! Success! So RLMeta now has Lisp-style function calls, and the other syntax for function calls is now gone. Yeah, so that works. So now we have Lisp-style function calls. And now I would like to add operators with the same syntax. So I haven't really thought about how to do that, but let's duplicate this line and let's call it op. And that should generate an op. This is the name of the operation. Yeah, sure. And then what is an op? An op is so it's plus or minus, and all the things we have. Let's write it like this instead. What operators do we need? We need plus, we need minus, we need multiply. Let's just do it like, let's make sure that this works first, and then we can add more operators. So if we write like plus plus, that would be an operator too, because let's do it like this just to begin with. And then in the assembler, when we see a call, we do something like that. But if we see an operator, what we instead want to do is AST. What is the name turned into var? It's turned into lookup. Okay. An operator is just the name of the operator. Okay, so let's do, this is just the name of the operator. And then we'll just do join ys with x. Let's save. And then this should be AST star ys. How about that? So that should generate a Python string, which is, let's do it like this as well. So let's surround it in parentheses, just to preserve precedence. So something like something like plus XYZ will be turned into an op with plus, and then maybe lookup of X and so on. And this will then be joined in the assembler to produce this one, and then the lookup X will be turned into something, let's call it X, and then join it with the plus, and Y plus, and then C. So that will be turned into a Python expression similarly to what we wrote in the semantic actions before. So this should be rather efficient as well. So let's see if, okay, so let's try to use this. I think this is everything needed. So let's try, we had the plus, we had the multiplication operator. So let's just try to do this. Will it work? This is rather interesting. One thing we can do is to have a look at like a more simple. Let's add the ML shift as well, so we can turn that one. So left shift would be this one. And I guess we have right shift as well, but let's ignore that for now. So this can now be written as plus left shift and we can also have a look at quite py file. Somewhere in here there should be an maybe the last semantic action. Let's see, somewhere here, yeah. So msum, mshift, this is an expression before, so let's save that for comparison. This was oops, int before, and then we have int after. Let's see, let's make sure this one is running from scratch. So now this is what we've got. So look at that. So now we have lookup B1. Oh, less than. Why didn't it consume? Oh, right. So in the parser, yeah, this will only return the last character. So here we need something like, this is the operator in Python. And now this should look better, yeah. So we have here lookup B1, left shifted 24, add it with B2. Yeah, this looks nice. Efficient Python code which reads rather nicely. Okay, so let's see if that actually works. Yeah. So another thing that I'm thinking about now that we have Lisp-style function calls is that This type of thing should perhaps also be written in a Lisp style. So because this is a bit confusing when you have multiple of these, so I'm thinking that there should only be one arrow per rule, so this should exist, but this should not exist, and this should not exist. So here's just a set of expressions. But this might read a bit confusingly, so if we combine that with some Haskell-ish stuff, we can have like a do statement. Wrap it in something like that, perhaps. Syntax is interesting, but yeah, I'm quite happy with Lisp-style operators. And I think this is probably a feature that should go into RLMeta.